we are going to generalize x to the linear function ax plus b, the whole thing to the power n. And when we differentiate this function, we will have same rule, put n to the front, then times ax plus b to the power n minus 1. For the inner function, when we differentiate the inner function, we have to multiply a. Similarly, when we look at the integration, the x has been generalized to the linear function ax plus b. We will have the result ax plus b all to the power n plus 1. And this one has been numerator, and denominator is n plus 1. And for the inner function ax plus b, when we differentiate, we times a for the result. For integration, we are going to consider the opposite operation. It means we are going to divide by a as part of the denominator. We add c for the indefinite integral. And also, n cannot be -1, a is not equal to 0. Here we have to emphasize we only generalize the formula to the case when the base is a linear function ax plus b. And in the differentiation, we times a. The integration, we have to divide a. Multiplication has been converted to division. Now let's look at example 2 by using the generalized formula. First, for the root sign, we are going to rewrite this as the power of half. Then we can see it is the compound function. The inner function is 2x plus 1, and the outer function is the power function. By comparing with the formula, n is equal to a half. Then we will need n plus 1, which is 3 on 2. Therefore, we will have 2x plus 1 all to the power 3 on 2. Over the new power 3 on 2. Don't forget the inner function, it's a linear function. The coefficient of x is 2. Now we have to divide the whole thing by 2. It means for the denominator we have to multiply 2. Record the lower limit and upper limit. Simplify the expression first. For the denominator, 2 and 2 cancelled out, we will have 3. Then 1 over 3 will become the coefficient of 2x plus 1 to the power 3 on 2. Then we are going to substitute. Third is the coefficient. Now we keep it outside. Then we will substitute 1. 2 times 1 plus 1, we will have 3 to the power 3 on 2. Then minus, when we substitute 0, 2 times 0 is 0. We will have 1 to the power 3 over 2. 1 to the power 3 over 2 is just 1. For this value, we are going to simplify by using the index law once again. So 3 to the power 3 over 2 is equal to 3 to the power 1 plus a half. It's 3 to the power 1 times 3 to the power a half. Simplified to 3 times root 3. Therefore, we will have 3 times root 3. Expand the brackets. We will have root 3 minus a third by distributing the common factor to every term in the brackets. By looking back at the process, we know when we apply this formula, it is very important to consider a in the denominator. That's all for this part. Thank you very much for watching. I will see you next time.